Hi. Today's session is starvation. What is a liveness? What is a fairness? What is a livelock? This type of small terminology. We already learned these concepts, but I am introducing some terminology to those concepts. In previous session, I told about deadlock situation. One thread is waiting for some other thread related object, like suppose if two threads are there, T1, T2. T1 holds an object A and waiting for B lock. At the meanwhile, T2 holding the object B and waiting for A lock. So two threads are mutually waiting for the locks, then these two threads are in waiting state forever. This type of a concept is called as a deadlock. Now what is the liveness? Liveness is simple. Suppose my processor is single processor or multi-core processor, you can take anything. What happens, my single core, one core processor, like that some core processors will be there. Now if you take core processor 2, it's a core processor 2, second processor CPU 1, CPU 2, simply. So my CPU 2 is executing some T3 and T4, like that it's executing. How it will execute? Concurrently, first core 1 will execute some part of T1, then it will shift to T2. After executing some part of T2, it will again shift to T1. After that, it will again shift to T2. Like that, it will do concurrently. One processor, within one processor, not multiple processors. Consider just one processor. Within the one processor, there are two threads are there. So what the processor will do? It will execute like concurrent manner. So this type of execution. So how thread scheduler will allocate some time 1 millisecond for T1. After completing 1 millisecond, it will allocate 1 millisecond to T2, for example. After completing this time, it will again allocate 1 millisecond. It will allocate 2 milliseconds. We can't fix this value. It's 1.5 milliseconds. 1 millisecond. Like that, thread scheduler is allocating the time for threads T1, T2, T1, T2. It will execute like this. So the time is managed by the thread scheduler. So thread scheduler is allocating the thread to run. So concurrently, two threads are executing after one, like that concurrently. So this type of time allocation is called as a liveness. So this type of concept is called as a liveness. So this is the concurrently the application able to execute concurrently. Some threads are execute in a timely manner. Some time thread 1 will take. After completing the particular amount of time, thread 2 will execute. After again thread 2 some particular amount of time, again thread 1 will execute. Like that, thread 1, thread 2, if up to terminating states, it will execute. It will allocate the time up to the termination. So this is called as a liveness. So there are problems in liveness. Means the thread allocating time here and here, some problems will come. What is the problem? Is we know already deadlock. So at the time two threads will execute. One thread is looking for one lock, and same thread, another thread is looking for this one lock. Like this deadlock situation occurs. Deadlock is the one of the disadvantage in this concurrent program. Next one is starvation. What is the starvation? Suppose in my application T1, T2, like this, some threads are there. Now like this 10 threads are there. How many threads are there? 10 threads. Now T1 came first to processor CPU. Now T1 thread came and executing. Sometime after some time T2 came. So it is in T1 is in ready state to from running state to ready state. Now T2 is in ready state. After T2, some part of T2, it will give the chance to T3, like this T10. After some part of T10, it will again give the chance to which thread we don't know. Based on priority, it will give. Suppose T1 thread has low priority, like 2. Then maximum the thread scheduler will not give the this one. It will give the chance to T2, T3, like that. Means sometimes what happens, some threads may be been waiting, maybe in ready state for some long time period. So some long time period. Deadlock means the threads are in waiting state for infinity number of time, forever. But starvation means the thread is in waiting for some most long time, like 1 hour, 2 hours, 3 hours. After completing all threads are some mostly taking time for this thread execution. We can't explicitly say this will take first priority or this will take second priority. We can't say. If maybe thread scheduler can recognize the priorities, fine. If not recognize, it's depending on thread scheduler implementation and OS implementation. We can't say if this thread will execute first and T2 will execute next. We can't say. But what happens in sometimes in this type of situation, some threads will be waiting for forever. So this type of situations are called starvation. Deadlock means the threads are waiting forever. Starvation means the threads are waiting for most long time, like 1 hour, 2 hours, 3 hours. We can't expect. Compared to remaining threads, this waiting period of this thread is mostly more. So how this occurrence, the starvation, if thread priority is very low priority. Otherwise, if all the 10 threads are locking on one object, a object, a dot wait, t1 execute a dot wait, t2 execute a dot wait, t3 execute a dot wait, like that. All the threads are waiting for a lock, and sometime some other thread came, a dot notify means one thread will come. The thread scheduler can allocates this notification signal to pass to any one thread only. Maybe T2 thread will come or T3 will come, like that. So in this type of situations also, these one threads are in most number of times. So long time of period it will be in waiting state or locks. Suppose the lock is not available, same lock is waiting for 10 threads. If you call notify all, maybe it will get the chance in lost. All the threads will come to ready state, but the allocation, it will come to running state maybe after completing of all the threads. It is called starvation, waiting. If thread can wait for more time by any, based on any reason, based on synchronization or based on locks or based on low priority, any reason, if thread is taking so much time to execution, to allocation execution time period, execution this time, the total time taken by T1 thread is 1 to 3.5 milliseconds. So this time allocation is very low. It is not allocating the T1 time to T1, it is thread scheduler allocating the time to remaining threads. So T1 will take so much of time to completion because the time is not allocated for T1. So this type of situations are called starvation. So that is deadlock means the threads are waiting forever. It will not come to ready state forever, not come. But starvation means the thread will come and thread will complete this execution, but it will take more time based on low priority or based on locks or based on more number of threads. We can't expect. So this type of situation is called as a starvation. Now this is starvation. Now what is a fairness? So it is not a fair if the thread is waiting that much of time. Suppose one thread came before 3 hours but still it is in waiting state because the thread scheduler allocating time for remaining threads, not for T1 thread. T1 thread came 3 hours before. So on this time what we will do is we will tell to JVM, you just follow FCFS, first come first serve algorithm. We have so many number of algorithms, round robin, SJF, shortest job first. So like that, but we are mentioning the thread scheduler, you just go for FCFS, means first come first serve. Means whatever the thread is first coming, you first serve that thread for particular thread only. Means this type of fairness I can set. If you create a one thread For the thread I can set the fairness. I can set the fairness. But in synchronization concepts, this fairness concept is not there. In advanced multi-threading like re-entrance locks, read-write locks, some explicit locks concept, I can set the fairness for that lock. Means whatever the lock thread is coming for first for this lock, just allocate this lock for that thread only. Like that I can set. In future sessions I will explain those concepts, fairness, like that. So fairness is nothing but to tell in JVM or thread scheduler, whatever the thread first coming, just serve, means execute or allocate the time for that thread only. So first comes first serve is nothing but fairness. And next concept is livelock. So starvation, fairness, livelock, liveness, four concepts. Liveness is nothing but allocating a time period concurrently, called liveness. Deadlock is nothing but waiting the two threads dependently, it's called deadlock. Starvation is nothing but waiting the threads, waiting a thread, allocating a time period to thread is very long delay, then it is called starvation. If you want to say, if you want to remove starvation, you need to go for fairness to giving a signal to the thread scheduler or JVM. First whatever the thread is coming for this lock, you just serve that, you just allocate the time for that thread only, that is called fairness. Now what is livelock? Livelock is also similar to deadlock. So one thread is locking A and one thread is locking B. Now this thread requires lock of B and this thread requires lock of A. Then these will go to in waiting state forever, means waiting for same lock. But liveness is somewhat different. The threads in waiting state forever called deadlock. The threads in ready state only, and waiting for each other. Waiting for each other means like, for simple example, one person is there and one person is there. This person is moving like this and this person is moving in this direction. Both the directions they are moving. It's a small door, only one person can allow at a time, but both the persons are trying to enter in at a time. So they are moving, means the threads are executing but not entering. So the threads are in running state only, but it is wasting CPU time. It is waiting CPU time, but the threads will do nothing because they are waiting. They are waiting for others execution in running state only. This type of situations are called as a live locks. Live lock means deadlock means the threads are in waiting state for waiting for some locks forever. Live lock means the threads are waiting for allocation of time or some allocation of resource in running state only. That is called live lock. That is called fairness and live locks. This is the type of a live locks. Means if you use a live lock, it is wasting CPU time cycles. Deadlock will not wasting CPU life cycle because the threads are already in waiting state. It will not consume any CPU processor time. But live lock threads will consume processor time, but it will not do anything because suppose like some empty while loop. If you write empty while loop, it will take CPU processor time but do nothing. Like that live lock will be there. So that is the difference between deadlock and live lock. So in next session we will go to discuss about what is daemon thread and what is thread dump stacks and what is the guardian blocks. Something like this type of concept we will discuss in next session. Okay, thank you.